Good morning, everybody. Thank you for joining me today. Another day of notes with Mr. Jankowski. We're on page 78 of our math notebook. And on this page, we're going to solve some equations. So I'm going to zoom in and take a closer look at page 78. There we go. And on the instructions, it says at the top, solve each equation, show your work, round to the nearest hundredth if necessary. So we know we're going to be dealing with some decimals here, probably. So let's take a look at the first one. I'm going to do a few of these examples. This is your independent practice for this week, so I'm not going to do them all, but we'll do a few and get you started here. So let's take a look at number one. Number one, we have 31 and 5/10 equals A minus 34 and 4/10. So make sure you're paying attention to those decimals. They're kind of hard to see here. Now what I want to do is I want to isolate A. I want to get A completely by itself. Because if I can get A by itself on one side of the equation, it will tell me what A equals. All right? And so let's take a look at what we can do here. We've got 31 and 5/10 equals A minus 34 and 4/10. I'm going to rewrite this down below where I can manipulate it a little bit and see it a little bit better. Okay. Now, to get this A by itself, I need to do something with this minus 34 and 4/10. Now, if you paid attention to the page on notes for page 77, you'll know that I can use the addition property of equality to add to both sides of this equation. And it's still true, as long as I'm adding the same number to both sides. So what I'm going to do is I'm going to add 34 and 4/10 to this side of the equation, and I'm going to do the same thing to this side of the equation. And when I mean side of the equation, this side of the equal sign. When I do that, minus 34 and 4/10 plus 34 and 4/10, well, that equals 0. That cancels itself out. So I can just cross that out, and I'm left with A on this side of the equation. I still need to work this out, 31 and 5/10 plus 34 and 4/10. So I'm going to do that over here. Give myself a little extra space. I'm going to line up the decimals because I'm adding decimals. When I'm multiplying, I don't need to do that, but when I'm adding decimals, I need to line them up. Okay, and now I'm going to add 5 plus 4 is 9. Bring that decimal down. 1 plus 4 is 5, and 3 plus 3 is 6. So A equals 65 and 9/10. Okay, so not too bad. Let's take a look at another one. Number 2. Now, number 2 is a little bit different. This time we have an addition next to our variable here, the operation of addition. So we have x plus 76 and 31/100 equals 164 and 48 thousandths. Or 164 and 89 hundredths. My mistake. So I can see that there is an operation here of addition. I know the subtraction property of equality says that I can subtract both sides of the equation by any number, and it's still going to be equal as long as I do the same subtraction on both sides of the equal sign. So if I subtract, let's use red. If I subtract, let's rewrite this, 76 and 31/100 equals 164 and 89/100. Hold on. If I subtract 76 and 31/100 from both sides, I can do that because I'm doing it to both sides of the equation. And by doing so, I eliminate 76 and 31/100 on this side, and I'm left with x all by itself equals 164 and 89/100 minus 76 and 31/100. So I'm going to do that over here. Just give myself a little bit of extra space. Whenever I'm working stuff out on paper, I want to make sure that I have enough space to not make mistakes. Or if I do make mistakes, where I can find them. So 9 minus 1, of course, is 8. 8 minus 3 is 5. Subtracting, so I'm just going to drop the decimal down. 4 minus 6, I can't do that. I'm going to borrow from the 6, make that a 5. 14 minus 6 is 8. And then 5 minus 7, I can't, but I could do 15 minus 7, and 15 minus 7 is also 8. So the answer is 88 and 58/100ths. Okay, I'm going to erase what I did here to make space for number 3. So remember, you can always pause these videos, go back, look at what we did again, rewatch them. Not a problem. Okay, this time we have a different operation. We have multiplication here. So we have d times 12 equals 48. Sometimes you'll see this as 12d, right? That's the same as d times 12. It's the same thing. So we know that the inverse operation of multiplication is division. So the inverse operation is division here. I'm going to divide, and I can divide both sides by the same number, both sides of the equation by the same number, and it's going to stay equal. That's the division property of equality. So if I divide both sides here by 12, d times 12 over 12 is the same as just d, because 12 over 12 is 1. So these get eliminated essentially, and I'm left with d equals 48 divided by 12. So I'm going to put this over here, 48 divided by 12. Now 12 goes into 4 0 times. So how many times does it go into 48? I'm assuming 4. So I'm going to do 12 times 4 on the side. 2 times 4 is 8. 1 times 4 is 4. So 4. So d equals 4. Okay, so that one's pretty simple. Not too bad. All right, and let's do one more example here. Let's find one that's tough. How about one of these fraction problems down below? Let's take a look at number 8. This will be the last one that we do today on notes. The rest will be up to you to complete for independent practice. So on number 8, we have 3 times x equals 3/9. Okay, so let's see what we can do here. Okay, sorry for the pause there. If you noticed that, I had to pause it for 1 second. Okay, so we're going to be working on number 8. 3 times x equals 3/9. And just like the one above, the inverse operation of multiplication is division. And I can use the division property of equality to divide both sides by the same number. So what I'm going to do here to get rid of this 3 and leave x by itself is divide by 3 on both sides. Okay, so I'm going to show you what this does. 3 over 3, of course, is 1, and that leaves x on the side. But what is 3/9 divided by 3? Well, of course, 3 as a fraction would be 3 over 1, right? And if you recall, when we multiply fractions, or divide fractions, what we can do is we can do this. 3/9 times 1/3, the reciprocal. If you recall the reciprocal, we multiply the reciprocal to divide fractions. So I'm going to multiply across here now that I've flipped the fraction we're dividing by. 3 times 1 equals 3, and 9 times 3 equals 27. So 3/27. Now 3/27, of course, can be reduced if I divide by 3. Let's do this. If I divide by 3 on both top and bottom to reduce this fraction, I'm going to get 3 divided by 3 is 1, and 27 divided by 3 is 9. So I end up with 1/9. X equals 1/9. Okay. So I think that was probably one of the more confusing ones, number 8, because we haven't divided fractions for a while. I'm going to zoom out and see if there are any others here that we can do that might be helpful. And let's do one more on the bottom row. Why not? We've got time. So let's take a look at, let's try number 11. Why not? Okay, so for number 11, we have 55 divided by x equals 5. And this could be rewritten like this if we wanted to. We could write it as 55 divided by x equals 5, if that helps you visualize things. So what can we do here? We've got 55, we've got divided by x. We need to get this x by itself, don't we? Okay, so this one will take a little bit of extra finagling, and I don't think that this is too hard, but it's going to take an extra step. We need to get this x by itself, but I'm going to take a couple steps to get to that x being by itself. The first thing I'm going to do is, because this is 55 divided by x, I'm going to use the multiplication property of equality to multiply both sides by x. Now just bear with me here. When I multiply both sides by x, these x's become 1 and can essentially be eliminated. And I'm left with 55 equals 5 times x, or just 5x. Now from here, I can use the division property of equality to divide both sides by 5. 5 divided by 5 is x, or 5x divided by 5 is just x by itself. 5 divided by 5 is 1, so we're left with x by itself. And 55 divided by 5 is 11. So x equals 11. So in this case, we had to do things twice. We multiplied both sides by x to get x from one side to the other of the equation, and then we divided by 5 to find that x equals 11. So some of you might be able to do these in your head. Like this one, you might have been able to figure out in your head without showing the steps. But it's important to show all of your work on these, and if you get stuck with any of them, let me know. We'll review them in class. We'll talk about them later. And I want everyone to make sure that they do their best to show their work and show the steps that they took to get to their answer. Have a great day, everybody. Thank you for watching our video notes today on page 78. Take care, and I'll